This e-learning provides important basics for commissioning of Thyristor power controllers. Thyristor power controllers are generally used for heating with electrical energy. The actuators control the electrical power for heating elements in proportion to the output required by a temperature controller. To vary the power controllers switch the mains voltage only temporarily to the heating elements, respectively to the load. The devices are often used in burst firing mode. In this operation mode, complete sine waves of the mains voltage are switched to the load or blocked. If, for example, a temperature controller requires 50% output, only half of the mains voltage full waves are switched to the load. With a required output ratio of 33%, only 1/3 of the mains voltage full waves are switched through. Burst firing operation is to be regarded as relatively unproblematic and should be used whenever possible. In phase angle control, only parts of each mains voltage half wave are switched through. The angle from ignition of the thyristor to zero crossing is called phase angle phi. The phase angle phi increases with higher required power. The angle can vary from 0° electrical at no required power to 180° electrical at maximum power. The main reason for using phase angle control is a required current limitation for heating elements with very low cold resistance. The operation mode results in a high interference potential and furthermore control reactive power. Depending on the application, mains filters and compensation systems must be used. Thyristor power controllers offer the possibility of subordinate control. For example, they control the electrical power in proportion to the required output of the temperature controller, even in the event of mains voltage fluctuations. For optimizing costs, the square of the load voltage is often controlled instead of the power. If the load resistance remains unchanged, the power also increases in this case in proportion to the required output of the temperature controller. Thyristor power controllers must be dimensioned at least for the current that flows through them when the supply voltage is permanently switched on. Apart from transformer operation, this corresponds to the rated current of the heating elements. Thyristor power controllers are available for different supply voltages. For single-phase actuators and for operation between phase and neutral, the devices must be chosen for phase voltage. If the elements are operated between two phases, the controllers are to be needed for the phase-to-phase voltage. The Thyristor power controllers for three-phase operation must always be designed for phase-to-phase voltage. In the following, the commissioning of a single-phase power controller is demonstrated. In practice, heating elements often have a nominal voltage equal to the phase voltage or phase-to-phase voltage of the respective low-voltage network. The elements are then operated directly via a Thyristor power controller on the low-voltage network. The power controllers must also be chosen for a supply voltage of the value of the phase voltage or phase-to-phase voltage. In the example, a heating element for operation on 24-volt extra low voltage is used. The power controller is also designed for a supply voltage of 24-volt AC. Dividing the rated power by the rated voltage results in a rated current of the heating element of 16.67 amps. A power controller for a load current of 20 amps is sufficient. The supply voltage is about 26 volt AC. To protect the heating element from overvoltage, phase angle control is used. U² is used as subordinate control, and the temperature controller requests the power via a 4 to 20 mA signal. The controller is operated via a fuse for line protection. The supply voltage is applied via a microfuse to supply the control electronics. The supply voltage is also connected to the heating element via the thyristors. The additional switch may become necessary when using an interface such as Modbus, Profibus or Profinet. It enables voltage disconnection of the heating element while the interface remains active. The power is requested via a 4 to 20 mA signal. UMO thyristor power controllers have extensive functionalities for operating infrared radiators, high-temperature elements and vibration drives. In general, configuration via a configuration program is recommended. However, since only a few settings are required for the application example, configuration via the device front is demonstrated. The settings are made in the configuration level. The measuring range of the current input must be set to 4 to 20 mA. The current input is used for setpoint setting. With a current signal of 20 mA, a maximum voltage of 24 volt is output. The power controller is used in phase angle control and the subordinate control is U². After configuration, a setpoint for the power is specified in manual mode for functional testing. Load current and load voltage are displayed directly. Finally, the setpoint is specified by the temperature controller. All electrical variables are available at the power controller for diagnostics. All information about our seminars, webinars, e-learnings and reference books are available at campus.umo.net.